Hi again. I messed up and did not share my screen at the end of the last video on how to use the spreadsheet. So let me try this again. So I'm going to open up here, share my screen, make sure I'm sharing it this time. So I'm going to go to the statistic formula sheet, open that up. And here's the t-test. So on the computer, it's different. So there's more information you have to put in. You have to put in the data for range 1, the first set of data. So this might be your non-texting data, which I just indicated was in boxes 1 through 10 in column A. Range 2 would be like your data with texting. So I said it would be in boxes 1 through 10, column B. And then you have to tell it the tails and the type. The tails, the tails are the two ends of the normal distribution curve. Remember, you had the normal distribution curve and the mean was right in the middle. Then you had 1 standard deviation, 2 standard deviation. The far ends, those 2.5% areas, those are the tails. Almost all the time, we're going to be using 2 tails because we're interested in both the high end and the low end. Sometimes you might only want 1 tail. So say you're a medical company developing a new drug, and you are interested in the negative effects this drug has on people. And so you would only focus on that end of the curve. You'd only focus on the negative end of the curve. In that case, you would set it for 1 tail. The other number that you have to give is you have to tell me whether it's paired or unpaired. Paired means the data was collected from the same organisms. So in our case, the texting data was collected from the people in the class, and the non-texting data was collected from the exact same people in the class. So both data sets came from the same individuals. So that would be a paired t-test. If we had taken half the class and done texting with reaction time, and the other half of the class did reaction time with no testing, our data had come from 2 different sample groups, then it would be unpaired. I'm not going to go into equal variance and unequal variance at the moment. For now, you'll basically be picking 1 or 2. 1 if it's the same group of individuals, 2 if it's from the 2 different sets of individuals. Hopefully that's making some sense. So let me open up a spreadsheet here. I'm just going to take this out so I can show it to you. So this is a sample problem. Just clearing it out so I can demonstrate it to you. So this particular experiment, we have an aquarium with plants and we have an aquarium without plants. And we were measuring some variable about the aquarium. And so I want to do a t-test to figure this out. So you're only going to get 1 value because you're comparing both columns. You're not going to get 2 values. You're only going to get 1 value. So I'm going to go up here and go equal t-test. It should be coming up here. Equal t-test. What is it doing to me? All right, we're having a small problem here. I'm not sure what's going on. I just did this a moment ago. It worked perfectly fine. I forgot to put the equal in. No, that's not doing it either. Well, anyway, equal t-test. I'm going to take my first range of data. Let's go from C2 or B2 to B11. I'm going to put in the colon or the semicolon, and I'm going to go from C2 to C11. Whoops, C2 to C11. I then need to put, actually those should be commas. I then need to tell it I want both tails. And this particular case, the data came from 2 different tanks, 2 different setups. So it's an unpaired test. And when I do that, I get a value. Sorry, that was not as clean as it should have been. But I get a value 3.41 times 10 to the negative fourth. So that translates the decimal place going 4 places to the left. So that's 0.000341. That's going to be the value. Now what that value is that's not a T absolute value. You're not going to take that number and compare it to the chart, the T critical chart. You will not be using the chart if you're using the spreadsheet. What this does is it directly gives you the percent probability. This number is the percent probability. If that number is less than 5%, and 5% is going to be 0.05, if the number is lower than 5%, you are in the outer edges of the tails. This is not a fluke. This is not an accident. There is a significant difference. You are going to reject your null hypotheses. So if it's less than 5%, 5% is the threshold. If it's less than 5%, you reject the null hypotheses. If this number was greater than 0.05, greater than 5%, then you would fail to reject because you're falling within 2 standard deviations of the mean. So just a couple other things to add. You got to make sure you add the tails, and you got to make sure you add whether it's paired or unpaired, and then understand what you're getting out of the computer, out of the spreadsheet program, is you're getting the actual percent probability. Less than 5%, reject. Greater than 5%, you fail to reject. That should have worked this time. So hopefully that helps you as you move forward working with statistics. Thank you for your time.